Okay, now that we've spent a couple days working on slope formula, we're going to go ahead and use the slope formula to help us write an equation of a line. And then what we're going to practice doing right at this point in time is using that equation to help us graph these lines and make it a little bit easier than doing those tables. Because remember back in chapter 3 we were doing those tables and all that work we had to do just to get points to graph, and hopefully we didn't make a mistake, because if we make one mistake it doesn't make our line look right. So now we're going to look at some shortcuts for that, using these formulas and patterns to help us graph. So our slope formula, M for mountain slope, so M equals slope, which is y2 minus y1, or our change in y's, over x2 minus x1, or our change in x's. So here's our formula written out. And in fact, I can write it this as M over 1, and then I can use a property from chapter 1 that we talked about called cross multiplying. And so I can cross multiply this way. So I get 1 times y minus y1 equals m times x minus x1. And that gives us this formula right here. Now, why did I change y2 and x2 to just x and y? Because when we have an equation of a line, there's always just a plain x and a plain y that represents every single point on that line. It can be any x and y on that line. And so in our equation, we're always going to have a plain y and a plain x that are always there. In our regular equations, though, these numbers here, y1 and x1, are going to be coordinates of a point. And m is going to be our slope. And so there's going to be real numbers plugged in here. Now, something else I want to point out to you is this is minus y1. So when we start looking at this formula, I'm actually subtracting the real value, which means I'm taking the opposite sign of what's there. And so here we have the same sort of thing. We have a minus x1, which means that I'm subtracting the real value, which means I'm bringing a negative right in front of the original. So when I'm looking at the formula, I need to think to mentally change the value of that sign. And so now we're going to look at our equation. So we have this equation right here. Y minus 1 equals 3 times x minus 5. And so remember, we've got this point in here. And our point, our x values with the x. So if it says minus 5, I'm actually going to have an x value of a positive 5. And then I have a minus 1 here. And remember, I'm subtracting the original, so I'm subtracting 1. So my original value is 1. And so what I'm going to do is I'm going to graph this point, because this is my starting point for graphing on my line. So I'm going to go to 5, 1, which is right here. And then I can graph every other point on that line by using my slope. So now what I have is I have a slope of 3. And so my slope of 3 is really 3 over 1, which means now I can go up 3, right 1. So from here, I'm going to go up 1, 2, 3, right 1, up 1, 2, 3, right 1, up 1, 2, 3, right 1. Now, I don't only have to go that direction, because this is really the exact same thing as moving backwards. I can go down 3, left 1. So if I start up here, I can go down 1, 2, 3, left 1. Hey, there's my point. Down 1, 2, 3, left 1, down 1, 2, 3, left 1. I'm back to my starting. I can, in fact, work backwards to find more points. Down 1, 2, 3, left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. And the reason why it's important to graph as many points as you can as possible, because it makes your graph accurate, and it gives you answers or true points on the line. Now, if your line's not accurate, it's going to give you the wrong answers, which is no bueno when it comes to math. We need to make sure our line's as accurate as possible. So we graph our dots, and then we connect them with a line that is hopefully as straight as possible. The lazier we get, the worse our line is, and the more inaccurate it is, which means then it's giving us wrong answers. Okay, so let's look at our next problem. We want our point, so the x value of our point comes from here. So if it says negative 3, we're using positive 3. The y value comes from here, so if it says positive 5, it's negative 5. And so now I graph that point, because that's where I start graphing. So 3, negative 5 is right here. And then I'm going to go ahead and I'm going to grab that slope. So that slope is 1/2, which is going to be up 1, right 2. So from here, we're going to go up 1, right 2. And then up 1, right 2. And then up 1, right 2. And then I can even work backwards. Down 1, left 2. So I can go back to my starting point, go down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. And that gives me my line. And so then I can connect all those dots with a really nice line. And that line represents every single point that is on that line and every single solution to that equation. Okay. So when we have another problem, because we keep throwing them at you, the more you see, the better off you do. So let's go ahead and start with our point. So here's my x value, positive 1, which means it's negative 1. Here's my y value, positive 4, which means it's negative 4 for my point. So I start at negative 1, negative 4. And then I'm going to go ahead and I'm going to use that slope. So the slope is negative 3 over 2. So I go down 3, right 2. So from here I go down 1, 2, 3, right 1, 2. Down 1, 2, 3, right 2. And then I even work backwards. I can go up 3, left 2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And see, again, the more dots I have, the more accurate my line should be. And there's our line representing all solutions to that equation. Okay, so looking at our next one, let's go ahead and look at our x value. This is positive 1, so that means it's negative 1. Then I go to my y value. It says negative 2, so it's positive 2. And there's our starting point, negative 1, positive 2. And then we move over to our slope, which is negative 5. So as a slope, it's negative 5 over 1, which means it's going to be down 5, right 1. So from here, down 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5, right 1. Then I can also work backwards, up. 1, 2, 3, 4, 5, left 1. And that gives me my line. Now the steeper your line, up or down, the harder it is to draw a good straight line. So anything like a cell phone, an edge of a notebook, that'll help you draw a good straight line through there. Okay, next problem. So we're going to go ahead and look at that starting point again. So we're going to look at the x. So if that says negative 8, we're going to use a positive 8. And we look at the y. If this is positive 3, it's going to be negative 3. So we're going to start at positive 8, negative 3. And that's how we start. And then we're going to go to that slope, which is 2. So that's 2 over 1 is slope. So up 2, right 1. So up 2, right 1, up 2, right 1, and we ran out of room. So we're going to use our trick to go backwards. So down 2, left 1. So I go back to my starting, down 2, left 1, down 2, left 1, down 2, left 1, and there's our line. Okay, next one. Let's start with our x. So it says negative 3, which means we start at positive 3. It says negative 8. So positive 8, so 3, 8, give me our starting point. And then we look at our slope, which says 0. So 0 as a slope is 0 over 1, which means we go up 0 and right 1. So I go up 0, right 1, up 0, right 1, up 0, right 1, which means I'm going straight across. I've got the idea. So now I can draw my accurate line totally across. Okay, last set. Let's look at our x. So it says plus 3, which means negative 3 for my x. Negative 6, so it's positive 6. So my starting point is negative 3, positive 6. Then I have a slope of negative. Well, remember, if there's no number there, that really implies that there's a 1. So my slope is negative 1. And then for a fraction, it's going to be negative 1 over 1, which means I'm going to go down 1, right 1. So from here, down 1, right 1, one of my favorite slopes, other than 0, because it gets really quick and easy to graph. And then I can work backwards, up 1, left 1. and it follows that same pattern. So then I connect it with a line. Okay, so next one, we go to our x. So it says -2, which means it's +2. I go to my y, it says 0, so it's 0. So I go to the point 2, 0, which is right here. And then my slope is 3/4. So I'm going to go up 3, right 4. So up 1, 2, 3, right 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And there's our line. Okay, so this is probably the most common way of graphing lines. We're going to talk about other exceptions and special cases, but pretty much for the rest of your mathematical career, this is going to be the way that we're going to be looking at graphing lines, because it is probably the easiest way to write an equation and one of the easier ways to graph any sort of line.